Hello students, welcome back. At OrganiChemVerse, you learn concepts by solving questions. So today we are going to solve some of the concepts of Grignard reagent, production of the groups, cyclization and reduction reaction by solving just one question. Let's get started. There are four reactions given here. You have to identify how many of the given reactions is or are correct. The first reaction, you can see there is a ketone and then there is a halogen. Then it is treated with magnesium in dry ether. It goes without saying that the reaction is done in anhydrous ether. Now what should happen? The magnesium will get inserted between carbon and bromine. Then we are going to get a Grignard reagent. The formed Grignard reagent here is correct. The structure of the molecule is correct. But will this be the final product? No. Because within the molecule we have a reactive center that is a ketone and Grignard reagent. How else you can write the Grignard reagent? You can polarize it as plus here and minus here. And you see the ketones are electron deficient because oxygen is electron negative element and it will take the pi bonding electrons, making this carbon electron deficit. Because this is electron deficit, within the molecule there is a Grignard reagent, so it will attack this carbonyl carbon and this will undergo addition reaction. Students, remember, aldehydes and ketones undergo nucleophilic addition reaction as they are electron deficient. Now, what happens to the oxygen here? It is going to combine with the MgBr. So the cyclization product, how many membered it will be? So count from here, 1, 2, 3, 4. So we are going to get a 4-membered ring like this. And you see on this carbon, it's going to be O minus MgBr like this. And look at this, since it's a ketone, right? So you know that ketones react with Grignard reagent to form a tertiary alcohol. Therefore, don't forget about this methyl. So altogether, how many carbons are there? 1, 2, 3, 4, 5. Check out here, there are 4 and 5. So this will be the final product. So this is partially correct, not completely correct, because there is an intramolecular addition reaction to form a cyclized product like this. So upon treating this with ammonium chloride, we will end up with the tertiary alcohol. Therefore, this reaction is not correct. Now let's check for option B. The given molecule is ethylene glycol, right? So ethylene glycol, it's a vicinal diol. What do you mean by vicinal diol? They are on the adjacent carbon like this. Geminal diol means the hydroxyl group will be on the same carbon. It is treated with an aldehyde. What aldehyde it is? Count the number of carbons. 1, 2, 3. It's a propanol molecule. So let's write down propanol molecule. You better elaborate the molecule like this. So 1, 2, 3 like this. So it is treated with a catalytic amount of an acid. Whenever we have an aldehyde and a diol, we are going to get acetal molecule. What is acetal? It's a geminal diether. That means what? Whatever the carbonyl carbon is there, right? So it will undergo addition like this, right? And then what happens? Again, this oxygen will attack here and then we are going to get a cyclic ether like this. And what do you call this as? We call this as acetal molecule. And when do we use such kind of acetal? Generally, in order to protect the aldehydes before we carry out some sort of reactions. And you can see that here, this and this products are exactly same. Therefore, this is a correct reaction. Now let's check for the third one. You see there is negative charge on the oxygen, all right? So this is nothing but enolized ketone. So the negative charge is not stable. What should happen? The electrons will shift here. Between carbon and carbon, there is a double bond, not stable, right? So because this carbon cannot become pentavalent. So what it does, there is a double bond in close vicinity to this. So what happens? It will again move like this. The pi bond will become sigma bond now. What will happen now? The pi bond will become sigma. And then these electrons will shift here. Finally, the bromine will leave as a bromide. In fact, this is the driving force here. The driving force here is that the bromide is ready to leave the moment this molecule gets cyclized. Therefore, you can see there is a ketone. There is a new sigma bond formed here. This is the new sigma bond, and then the pi bond is still remaining as it is. So this cyclization is forming tricyclic molecule. So this is a final product which is correct. Therefore, third reaction is also correct. Let's check for the last reaction. So we have a ketone and then there is a halogen within the molecule. It is treated with sodium borohydride in methanol at 25 degrees Celsius. So what happens? This is a mild reducing reagent. It will reduce the ketone to a secondary alcohol. What about the halogen? That will remain as it is. Nothing changes with the bromine. Suppose if we would have used lithium aluminum hydride, it would reduce the ketone as well as displace this bromine by hydride. But here this is correct. There is nothing wrong with this reaction as well. Therefore, the fourth reaction is also correct. So among the four reactions, reaction 2, 3, 4. That means three reactions are correct. So students, you have seen, right? By just solving one question, you have revised so many concepts. I have included one more question at the end of this video. Please do solve it and comment your answer to know the key. Thank you. Until next time.